Okay, good afternoon. Thank you all for being here. We will discuss virtual threads, structured concurrency, and scope values, the three important features of Project Loom. And we will also see how they come together in a Spring Boot application. So I was here last year as well, and I also talked about virtual threads. But then at that time, I went one level deep and spoke about continuation, which is actually the foundation onto which virtual threads have been built. You can also find the talk here. But this year, I want to go one level higher, and I want to talk about different features that have been built using virtual threads as their foundations. So let's get started. But first, a quick intro about me. My name is Balkrishna. I work for ING Bank. So Project Loom. What is Project Loom? It is actually one of the important projects at OpenJDK. And the purpose of Project Loom is to provide high-throughput, lightweight concurrency, one which is also easy to use. And it does so by providing these three features: virtual threads, structured concurrency, and scoped values. And those are the things that we'll see in this talk. But before I begin, I want to ask the same questions I asked last year. So please raise your hand if you are using JDK 21, so Java 21. It doesn't have to be production. It could be anything. It could be a simple application. Looks like 50% of the room, or maybe slightly less. So now all the people who raised their hands have the possibility to use virtual threads. So now please raise your hand if you are using virtual threads, even for experimenting. Okay, less than 10%. That's really low. Okay, this could be more. But thanks for raising your hands. So what we'll do in this talk is we will actually create a Spring Boot application, and then we will add these features: virtual threads, structured concurrency, and scope values one by one. And then we'll see how they come together, how they work with each other. And we'll also see, more importantly, that with these features, we can write readable concurrent programs. Okay, so let's start with the first feature first, virtual threads. Now, what we see here in this picture is actually an instance of JVM, which is running on some operating system. The JVM has some virtual threads, also has few platform threads as well, and then OS has OS threads or kernel threads. Now, let's start with platform threads. So platform threads provide a thin wrapper over operating system threads. What does that mean? It means that when JVM wants to create a new thread, a new platform thread, it actually requests operating system to create a new OS thread. And only when that OS thread can be created, it creates the platform thread. And because of that, these platform threads, they map to the OS threads with this one-to-one mapping. And creating a platform thread is actually a resource-intensive task, right? You don't want to do that too often. So when you are done with a platform thread, you don't throw it away. You put it in a pool. You put it in a thread pool, so that next time when you need it, you can get it from that pool. So that's why platform threads require thread pools. Now, virtual thread, on the other hand, are lightweight user threads. Lightweight meaning they require significantly less memory, and because of that, we can create them in abundance. We can create thousands or even millions of virtual threads, and that makes them highly scalable. There's actually one more thing that makes them highly scalable, and we'll see that on the next slide. But another thing to notice about virtual threads is that they don't require pooling, because creating a virtual thread is a very cheap operation. So when you are done with a virtual thread, you just throw it away, just garbage collected, and therefore the next time when you need it, you can create a new one, right? You don't put it in pools. In fact, pooling virtual threads is an anti-pattern. You don't want to do that. Now, what we see here, that some virtual threads are connected to platform threads. Why is that? That is because a virtual thread on its own cannot execute anything. It really requires a platform thread to execute something. But then what about these other virtual threads which are not connected to any of the platform threads? Well, for those, we have a virtual thread scheduler. This is a newly introduced scheduler along with virtual threads feature. And what this does is it actually mounts a virtual thread onto a platform thread when a virtual thread requires platform thread, and it unmounts the virtual thread when it does not require platform thread. Now, what would be the scenarios where a virtual thread would not require a platform thread? It would be when a virtual thread is waiting for something. Let's say it is waiting for a network resource to be available, or it is waiting for database to return something. In all these scenarios, virtual thread is not doing anything. It is not processing anything, so it does not require CPU, so it gets unmounted from the platform thread. And in a typical IO-bound application, threads spend a lot of time waiting. And all of that waiting can be avoided if we use virtual threads. So if we use virtual threads, right, your CPU would be highly efficiently utilized, and that's what makes virtual threads highly scalable. Now, in this entire endeavor of mounting and unmounting virtual threads, the platform threads are carrying virtual threads. Therefore, they are also known as carrier threads. Okay, that's a lot of theory about virtual threads. Now let's go ahead and create a simple web application and see if we can add virtual threads to it. Now in this case, I'm actually using Spring Boot to create that. So I'm using Spring Boot 3.4, and I'm using JDK 25. More specifically, I'm using Project Loom early access build of JDK 25. So we get the latest and greatest features of Project Loom. And I'm using domain, which is close to me. So I'm going to write a banking application. And I'm really good with names, so I'm just going to use a very creative name for a bank. It's called a bank. So let's do that. Let's create a simple Spring Boot application. And I think the font is really small for especially audience in the back, so I'm going to try and increase it. Zoom this to the max level, so it can't get any bigger than this. And I hope you can still read it in the back. Yeah, OK, I get thumbs up. So this is a Maven application, and it has two Maven modules, a bank and services. So basically, a bank is the one where all the business rules are going to reside, and then services are the services that this module will use. Both of these are Spring Boot applications. So for the first demo, I'm just going to create a very simple controller, nothing to do with banking, and I'm going to call it Hello Controller. And this will be a REST controller, and it will have a method public string hello, which basically just says hello. Okay, and this method is exposed with a get endpoint, and the endpoint is also called hello. Let me start this application. And when I start this, I will quickly show that it is actually, it's going to run on port 8082. So let's send this get request, localhost 8082, hello, and it should say hello back to us, and it does. Okay, but I'm curious which thread it is sending this hello message from. So I'm going to add something here. I'm just going to say from thread.current thread. So we know which thread we are getting this message from. Restart and then go here and send the message again. Now we get the message from a thread, which is actually a platform thread, right? And I want to enable virtual threads here. I want to get a message from a virtual thread. So with Spring Boot, it is actually pretty easy. I can just go to the application properties and then add spring.threads.virtual.enabled. And then enable this. So I'm just going to set it to true, restart, and then send the message once again. And I get now hello from a virtual thread. So basically, this Tomcat handler 0 is a virtual thread. And what Tomcat is doing is it actually creating a new virtual thread every time I send a request to it. And then that new virtual thread is serving our requests. So we have basically transformed this application to a new world with virtual threads. Now, how can we use this new transformation, this new power? Well, many ways, and one of the ways that we're going to use that is by using structured concurrency. So in this next section of this talk, we'll explore structured concurrency. So structured concurrency is a feature that allows us, that provides us these control structures that are very useful for us when using concurrency aspect in our programs. So the first thing we'll see is that virtual threads enable structured concurrency. Well, how do they do that? With platform threads, we have a limitation that we can't create too many of those, right? So we create a limited number of platform threads, and we use them very efficiently. In fact, we look at a platform thread as a presentation of a process, and then we submit multiple tasks to it. With virtual threads, that limitation is not there. We can create many virtual threads, quite a large number of them. In fact, we can create a new virtual thread for every task. And then we can arrange these tasks in such a structure that represents our business logic in the most logical way. Right? And that is what structured concurrency is. And that's how virtual threads enable structured concurrency. In fact, the term structured concurrency is inspired from the term structured programming. So the way structured programming helps us to write readable programs, structured concurrency helps us to write readable concurrent programs. Now let's look at a few examples where we can use structured concurrency. So here in the first example, I have a main task which is creating 3 subtasks, and when all these subtasks are finished, I'm continuing with my main task. In the second example, again, I have a very similar thing, except that I'm not waiting for all the subtasks to be finished. So as soon as one of the tasks is finished, I'm continuing with my main task. And then a bit more complicated example. So here again, I have 3 subtasks, but when tasks 2 and 3 are finished, I'm creating a 4th subtask, and then after 1 and 4 are finished, I'm continuing with my main task. Now, all these examples can be implemented using structured concurrency, more specifically using structured task scope API. We'll see that later, how we can do that. But the important thing here is that when we implement these using structured concurrency API, that all the implementation, the code, looks very much similar to these structures. So it basically resembles the structure that we have of our tasks. Okay, we'll explore that in the later part of this talk. But some more things about structured concurrency. So the principle here is that when flow of execution splits into multiple concurrent flows, they rejoin in the same code block. For example, here we have a main task which is creating 3 subtasks. So this forking and joining happens in the same code block. We'll see that with an example. And this brings some advantages. So this gives us certain benefits. Now, the first benefit is that it allows us to do error handling with short circuiting. What does it mean? So here we have 3 subtasks, and we actually want the results of all these subtasks to continue. But what if one of them fails? Right? If one fails, there is no point in continuing the other 2. So when you have a failure in one, the other tasks are immediately cancelled, and that is what short circuiting is, and that is the benefit that we get with structured concurrency. Also, cancellation propagation. So if your main task is cancelled, that cancellation is propagated immediately to the child tasks, and those tasks are also cancelled. That is what cancellation propagation is. Clarity. So we talked about this structure, right? And when we implement this using structured concurrency API, we see that the resulting code resembles this structure, which brings in a lot of clarity. Again, we'll see that with some examples. And finally, observability. So what we have here is that we have a main task, which is creating 3 subtasks. Now, each of these subtasks can have their own subtasks, and those can have their own subtasks. So you can have a big hierarchy of these tasks. And because we want to create a virtual thread for every task, we can have a big hierarchy of virtual threads, right? And at any point in time, like if you have a problem and you want to get a thread dump of this application, you can get it in a format where that hierarchy of virtual threads is visible. And that way you can trace a particular thread, and you can fix the problem if there is a problem with that particular thread. So that is also the observability benefit that we get with structured concurrency. Okay, now that's again a lot of theory about structured concurrency. Let's see how the API looks like and how we can use it in our application. And for that, I'm actually going to add a new feature to our A-Bank application. And this feature is called loan application. So what happens here is that a customer applies for a loan, and then the first thing that we do is we get the customer details. So we get the details of that particular customer, and then using those details, we actually get their accounts, their loans, and external credit scores. For calculating external credit score, we have 2 services, but we are only interested in response from one of them. And then when you have all of those details, we basically send it to an offer calculation service where we finally get an offer, and then we send that offer back to our customer. So this is the feature that we are going to implement using structured concurrency API. But let's first see how does it look like with task structure. So if we put them in a structure of tasks, how would it look like? It looks like this. So here you have the first thing that you do is you get the customer details. That's our first task, right? And then you get using those customer details, you get the account details, loan details, and credit score. And when you have all of that, then you do calculation of the offer. And again, this getting credit score is not a, let's say, single task. There are actually 2 tasks behind it. But here in this case, we are only interested in one of them succeeding. We are only interested in one credit score. Okay, so let's go ahead and implement this in our A-Bank application. Thank you very much for the pictures. Okay, so before I implement that, I just want to show you what is there in the services app. So here I have a customer controller, which is actually exposing a lot of endpoints, and they are exposing certain services. So basically, you can get customer details, the credit scores, and accounts, loans, and calculation of the offer. So all of these services are present in the services app, and we're actually going to use these services from A-Bank application. So we're going to create different tasks here in A-Bank, and those are going to use these services. So that's how we're going to go about this. So let me first create the controller called loan controller, and this would be again a REST controller, and this would have a method which returns an offer, and the method is called apply for loan, and this takes some input, which is loan application request, called request, and let's say for now it is just returning nothing, running return null. Now let's say this is also exposed as a post endpoint, and the endpoint is loan application, and this is obviously our request body. Okay, so let's define these DTOs. For that, I'm gonna go over here and create a new interface called model, and I'm gonna generate a bunch of records here, and I have a live template for it, so that I don't have to type all this code. So all these records are now generated for us, and I'm gonna use these records all throughout different layers of our application for simplicity. Also, I have this a bank exception, which is basically an exception which is used to handle all these kinds of errors. Okay, so with that, we have the first version of our loan application service. Now, the first thing that we want to do here is get customer details, and for that, I'm going to create a new service called customer service. And again, I'm going to generate some boilerplate code using live template. So I have stuff here. So customer service uses a REST client, and this is a bean which is defined in this application. And what it does, it just connects to the services app that I showed earlier. There's also a logger here, and there's a method get customer, which is supposed to get the customer details using the REST client. So let's write that logic here. Customer is going to be from REST client. We'll execute get with this URI. This would be customer/ID, and we pass in the customer ID, and then retrieve the customer details. Okay, now that we have got the customer, we just send it back. So this way, we have now defined a get customer details task. Now let's use this service in our loan controller. So basically, we're going to inject that here, private customer service, called customer service, and let's inject that into the constructor, and let's use it in our loan application method. So here, what we're going to do is we do customer service dot get customer, and then we are going to pass the customer ID to it, and this would give us our current customer. Now, there is something very interesting happening here. So this method called get customer is actually a blocking call, because what we are doing is we are going over the network to fetch the details of the customer. And if that is the case, typically what you do is you don't want to block your current thread where this is getting executed, right? So you do some ceremony around it. You either return a future or a completable future, and then you do then something method on it, so that you get access to the result, and then you use that in some kind of callback. But all that ceremony is not necessary here, because we are operating in a virtual thread world. So with virtual threads, you don't make differences between blocking and non-blocking calls. You just make simple blocking calls, and then all that efficiency would be handled by the JVM underneath. So this makes our code, again, easy to read, increases the readability. Okay, so we have the current customer, and the next thing that we need to do is get the account and loan details. Again, let's skip the credit score task for a moment, and now let's get account and loan details, and let's say when we have both of these, we can continue. So let's add these services and then use them in our loan controller. So let's add the first service, which is account service. And again, it is very much similar to customer service. So again, I'm going to generate the whole thing. So here we have, again, it is using REST client and some logger. It has a method called get accounts info, which basically uses REST client to get all the accounts. So it returns a list of accounts. And then I'm going to create the next service, which is loan service. And again, I'm going to generate the whole code here, loan service it is very similar to the other services that we created with the REST client. It is going and fetching the loan details, in this case returning a list of loans. Okay, now let's use these services in our controller. So I'm going to use first the account service called account service, and then the loan service called loan service, and again inject them here in the constructor. It's easy to regenerate the constructor, so I'm just gonna do that again, and then use them over here. So first would be account service, and then it's gonna get the account details of the current customer, and then I'm gonna use loan service, which is going to get the loan details of the current customer. Now these two tasks, we want to execute them concurrently, right? That's why we're gonna use structured concurrency. More specifically, we are going to use structured task scope. So this has a method called open, which gives us an instance of scope. So this would be scope, and because there is open, there has to be a close method. So we're going to put this in try with resources. That will take care of calling the close method. So this way we get a scope. What can we do with the scope? We can use it to fork tasks. So I'm going to fork a couple of tasks here. And when you fork these tasks, what it does, it actually creates a new virtual thread, and it executes that task in that virtual thread. So here what is happening is it is creating two virtual threads for each of these tasks. So I'm going to call them task 1 and task 2. Okay, so I have created a scope. I have forked tasks which are now running in their own virtual threads. The next thing I can do is scope.join. This will ensure that both these tasks are finished. So here you wait for both the tasks to be finished, and then you continue from there. And I need to do some exception handling. It's basically catching the interrupted exception. In this case, I'm just going to throw a bank exception. And now that I have ensured that both the tasks are finished, I can get the results of these tasks. So I can do task1.get, and that gives me accounts. And then I'm going to do task2.get, which is going to give me loans. Okay, now that I have these, basically I have taken care of these two tasks. Now let's implement something for getting the credit score. For that, I'm going to create a new service called credit score service. Okay, again, it is very similar to the other services. So I'm again save all the typing and then generate some stuff. It is using REST client and again executing calling some services. So in this case, I'm going to use this method twice to get both these credit scores. So first, I'm going to get a credit score which is credit score 1 for this customer, and then I'm going to get credit score 2. So that's basically what this is. Again, these two tasks, and they are running concurrently. So I'm going to use structured concurrency here, and the same thing that we did in the loan controller, we are going to use structured task scope and call this method open, and that gives us a scope. I'm going to put it again in try with resources, and then fork tasks here. So scope.fork, this is going to fork this task, and then scope.fork again. Okay, and now the next thing, well, basically scope.join to make sure that we join here, and again some exception handling, and I'm going to again do the same thing, throw an ABank exception. So we did exactly same as what we did in loan controller. So this is again going to do the same thing. This is going to wait here for both these tasks to finish, but that's not what we want, right? What we want is we want to basically continue as soon as we have results from one of them. And how can I do that? Well, for that I'm going to pass a joiner to this open method, and there are a bunch of joiners available here. And I'm going to use this one, any successful result or throw, because what that does is it continues whenever there is a successful response from one of the subtasks, and that is exactly what I want here. So at this join method, it is going to wait for only one of them to succeed, and then it's going to continue from there. So basically, when you have one task successfully completed, you actually have the response from that. So join actually returns that response, and that response is of type credit score. So this will return credit score, and I'm just going to put that in score and then return that score over here. So that way I get the final credit score, which is basically the output of this. right? So now let's use this credit score in our loan controller, and for that I'm just gonna add a credit score service here, and again regenerate the constructor for the injection of our dependencies, and then over here I'm just gonna add a task 3, which will be scope.fork, and in this case I'm just gonna use credit score service dot get credit score for the current customer, and then here I can get the credit score from task 3 dot get. Okay, so now that I have ensured that I have all the data, I can continue and call this calculate offer. And for calculate offer, I'm just going to create a method in loan service. So here I'm going to add calculate offer, again generate the method because it's pretty much same as what is happening in everywhere else, calling the services app a particular endpoint. In this case, it is the one that is creating loans offer. So this returns an offer. And now I'm going to call it here because I have everything that is needed. So I'm going to do loan service dot calculate offer and then pass everything. So current customer, and then accounts and loans and credit score, and then I'm going to pass request dot not customer ID but request dot amount, and then request dot purpose, because that is all that is needed to calculate an offer. Okay, when we do that, we are going to get an offer, and that is what we are going to return from here. So finally we have an offer. Okay, so I think we have everything covered now. So let's see if we can run this and that we can actually get an offer from our A-Bank application. For that, I'm going to restart this, and I also have to ensure that the services app is running, because services app basically are services providing these dummy responses. So let's go over here and let's run the loan application endpoint, and I'm going to run this with some customer ID, some amount, and some purpose. So let's run this and see what is happening on the server. So I'm going to go to A-Bank application and check its log. So what is happening here is that we first do the get customer call. So that's the one that is getting the customer details. That happens successfully. And then we do get accounts info, get loans info, and both the credit score. So basically all these tasks are now running parallelly. We get the accounts info, and well, here we have both the credit score finishing. That happens very rarely. Again, this is we are dealing with concurrency. So actually both these credit scores have returned exactly at the same time. So one of them would be ignored and the other score would be used. And then we have loans info. So we basically have everything that we need for our offer. So we send it to the calculation offer, and then that gives us an offer, which I think we can see it over here. So we get the response with the offer included in here. I want to show one more thing over here, and that all these tasks are getting executed in virtual threads. Because initially we start with the virtual thread, and again we use structured task scope, which creates these virtual threads and execute these tasks in those virtual threads. So let's take a moment to see what we have done is there. We have used this structured task scope API at two places. So we use it here in loan controller, and we also used it here in credit score service. And in both the places, what we did was we followed a 4-step process. So we first did structured task scope.open, that gives us a scope. Then we fork the subtasks, then we join them, and then we get the results. So that's the pattern that we apply everywhere where there is structured concurrency API to be used. The only thing that we have to keep in mind is that to use the right joiner, because that defines the joining logic that you want. So here in this case, because we want one of the tasks to be successfully completed, we used any successful result or throw. So use the right joiner. Now I have this implemented using structured concurrency API, which is which provides an imperative API, but I could implement this with completable future, and actually I have done that, and I'm going to show you how that looks over here. At first glance, you see there is more code, and secondly, it is slightly less readable. Again, you know, when you use completable future, the one thing is that completable future takes over your entire code base. You basically see it everywhere. And another thing is that it uses callbacks. So if you have nested callbacks, then your readability reduces as well. And also debugging is a bit more difficult when you use completable future. If you use structured concurrency API, on the other hand, it provides an imperative API, which is easier to read. So it is difficult to mess this up, but with completed future API, yeah, with callbacks, it is easy to mess it up or at least get it in a form which becomes difficult to read. Okay, I'm going to show you one example where things are going wrong. So let's say we have let's open the loan customer controller, where I'm just going to say the accounts, let's say service is failing. So let's say we get an error with the account service, and in the loan control, I want to handle that exception here. So let me first add a logger here, because I want to use that in handling the exception. And here I'm going to add a branch to handle a failed exception. So this exception is thrown by join when something goes wrong. And again, it's a runtime exception, so you don't have to handle it, but I'm doing it because I want to log something. So I'm just going to say logger.error, and then I'm going to say failed exception, and then log the message from the exception. Okay, now I'm going to restart both the applications. So A-Bank application as well as services application. And now remember, the account service is failing. So this is failing, and it should trigger the short circuiting. So it should basically cancel all these subtasks. So let's see if that is what is happening. Now let me send the request here. And then we go to A-Bank application and check its logs. We see, well, something going wrong. So first is the get customer is returning successfully, but then it starts accounts, loans, and all these credit score services, but something fails. So here we get failed exception, and the accounts service is failing, and therefore all the other tasks are cancelled immediately, and what we get here is 500 internal server error. Yeah, you can have a different exception, but basically you get the idea how the exception handling is working in structured concurrency. Okay, I'm going to go quickly back here and set this up right, so I don't get exception again. Then let's move on to the third part of this talk, which is scoped values. That's the third feature of Project Loom. So for discussing scope values, we should also discuss ThreadLocals. And ThreadLocals, when you have a variable defined as ThreadLocal, each thread gets its own copy of that object, and that gives certain advantages. So there are a bunch of things which ThreadLocals are useful for. For example, request or session specific data. If you have a server which is operating in thread per request model, so every time you send a request, it is creating a new thread. You can use ThreadLocals to store request or session specific data. Also, it is useful for resource management of non-thread safe objects. So if you have a class which is not thread safe, what you can do is you can use that along with ThreadLocals. So you can have ThreadLocal instances of that class, and that way each thread gets its own instance, so there is no issue with the class being not thread safe. Also caching, you can use ThreadLocal for caching in the sense because you can store with a thread some data as ThreadLocal, and then the entire thread has access to that data, and also it is easy to then invalidate the cache. So it could be used. You could use ThreadLocals for caching and storing of observability information like correlation ID. It is quite logical because then in case of ThreadLocals, the entire thread has one copy of an object, and then different threads have different objects, and therefore it's basically a pretty good use case for objects such as correlation IDs. Now, platform threads support ThreadLocals obviously, but also virtual threads support ThreadLocals. So all these use cases you can also have them with virtual threads, but there are some problems with ThreadLocals. For example, unconstrained mutability. So with ThreadLocal, you have two methods, get and set, and you can do that anytime in your thread, and that basically gives all these problems of shared mutability. Also, unbounded lifetime. So when you have a ThreadLocal set on a thread, you have to explicitly call remove, right, when you are done with that ThreadLocal object. But developers often forget to call that remove method, and therefore the ThreadLocal stays with the thread. So sometimes you get a thread from a thread pool, and it has some ThreadLocal with some data in it, which is pretty unexpected. That could also get your application in some inconsistent state. So you have to be careful with ThreadLocals there. Also, expensive inheritance. So when you have a thread and you start some child threads, if you are using inheritable ThreadLocals in that thread, they are copied to the child threads. And if you're dealing with virtual threads where you create thousands of threads, all these objects are copied 1,000 times. So it takes a lot of memory. Now, all these problems magically go away when you use scoped values, because scoped values are immutable. and therefore the issues with shared mutability are not there. Also, with scope values, all allowed threads use the same copy. So again, the problems with increased usage of memory are not there because the same copy is used by all the threads. And they are inherited through structured task scope to the child thread, child virtual thread. So we'll see that with examples later on. And finally, they are bounded by the scope. So here you have an example where a scoped value called value is being set to some value, and this some value is only accessible in the bounds defined by these curly brackets and nowhere else. So again, you don't have the issues of unbounded usage of the thread locals here. Okay, let's go ahead and see some example by exploring the scoped values API. For that, we again go back to our ABank application, and what I want to do here is go to the loan controller. And what we see here is that we get, the first thing that we do is we get the current customer, right? And then we pass that current customer to every other service that we are using. Basically, all these services are operating in a context where we have this customer, right? So if we use this customer and put it in some scoped value, right, in the context, then all these places, we can read that value from the scope value, and we don't have to pass this parameter explicitly. So that's what we're going to do. We're going to remove all of this and put it in scope value. But before that, I want to refactor this code a little bit. So I'm going to take all of this out and put this in a method called get customer info. And this is going to return a customer info. Customer info is going to be a record, and that will be returned by this method. And these calls to offer, I'm going to move them from here and then keep them here. So how do we get the customer info record from here? It's basically return a new customer info with accounts, loans, and credit score. That's it. So we get the customer info, and this would be customer info, and then I can use that over here to send this data. Okay, so what I have done is I have just moved the part which used structured task scope, structured concurrency API, into its own method, and then rest is the same. So this is basically behaving exactly the same. Okay, I don't need request, so I can remove it from here, and I can also remove it from here. Okay, and now let's add request context with scoped value. So what I'm going to do is I'm going to create a new class called request context, and I'm going to add a scope value here. So I'm going to define a public static final scoped value of type customer called current customer, and gonna initialize it. So this would be scoped value dot new instance. Okay, and now I can basically set the value the moment I have the details of the customer, and then use it everywhere in my service. So let's do that, and this would be this point. So at this point, I'm just going to do scoped value dot where, and then I'm going to say a request context dot current customer would be this, and with this call something, and then that call would be all of this. So basically, you execute all of this in the context where you have current customer set, and I can return this. And now I have current customer in my scoped value, right? And then I can use that over here. For example, in get customer info, I can simply remove this customer from here, and I can get the customer from the request context dot current customer, and I can either use get, or I can use a safer option, which is or else throw. So this would be new ABank exception saying no customer. Okay, so this way I can basically get the customer in all these places, but what I like to do is I prefer to make this private. So that way you only deal with the scoped value inside the class that you define it, and nowhere else. And it exposes more domain specific API outside. So for that, I'm going to generate a couple of methods here. request context methods. So there are a couple of methods. One is with customer, which sets the customer, and there is get current customer, which gets the customer. And there is a bit more code to make sure that we can call this method. Again, I'm going to share the link to this source code so you can take a look later what is happening. But basically with this, what we can do is in loan controller, instead of dealing with the scoped value, we can just use request context dot with customer and set the customer. And then in here where we need the customer, instead of doing all of this, we can simply do get current customer, and that's much easier to do. Okay, so I'm going to do that at multiple places. So not only in get accounts info, but also in get loans info, because then you don't need to pass the customer. You get it from the context. Also here, I don't need to pass the customer. I will get it from the request context. Similarly, in get credit score, I don't need to pass the customer. I don't need to pass the customer here as well, and also not here. It feels good to delete code, right? And then get the customer here using the context. I'm going to delete some more code, so delete all of this because I don't need to pass the customer here. Again, not here. Also here, I can delete it. Yeah, should have used refactor from IntelliJ, but okay, I can delete it from here as well. Now, yeah, it becomes more concise, also more readable, and there's extra advantage that I can actually change all of these calls to method references. So not lambdas, but method references. That makes it even more readable. Okay, I think everything is done now. All these calls are using current customer. And one interesting thing is that with structured task scope, all these virtual threads, they also have access to the same scoped value. So we don't need to pass it explicitly. The child virtual threads have access to this scope value as well. Okay, everything is set. I'm just gonna restart the A-Bank application, and just to make sure that services are intact, I'm just gonna restart that. And now send the request, and let's see what happens. So when we send the request, we go back here to A-Bank and then check what is happening here. We first get the customer details, then we get the loans, or we at least send a request to get the loans details, account details, the credit scores, both of them. And in this case, credit score 1 responds back with a response faster, and therefore the credit score 2 is cancelled because you only need one score. We have accounts, loans details, everything is there, so we do calculate offer, and we finally get the offer, which we then send back. So we see it here. So that way we can use scoped values to also write some more readable concurrent code. Now, I think I have some time, so I'm gonna play around with the unhappy scenarios, and I'm just gonna show a couple of unhappy scenarios just to get a feel of how the structured concurrency API works. For that, I'm going to go to customer controller, and here I'm just gonna say that let's say the credit score 1 service is failing, and this gives us, let's say, throw new runtime exception, doesn't matter, error. So let's say credit score 1 is failing. Let's restart a services application. So what this would do is that, let's go back to our previous picture here. So one of them is failing. Let's credit score 1 is failing. So this is actually pretty interesting because even though this is failing, this is working fine, right? So we should still be getting our offer here. And in order to see that that is what is happening, I'm just going to go to the credit score service and add some exception handling. Let's put this in a try catch. And handle a REST client exception and log something. Let's say log error saying there is a REST client exception, and then we say e.getMessage. Okay, and then also here I'm just gonna handle failed exception and just gonna log something, log.error, failed exception, and this would be e.getMessage. Okay, so what I've done is I've added some logging in the credit score service just to make sure that we see what is going wrong and what is not. And the scenario that we are trying is credit score 1 is failing, but credit score 2 is good. Okay, let's send the request and then see what happens here. If we do that, we go back to the eBank application. Let's look at the logs. So what happens here is we first get the customer details, which works fine. Then we try to get accounts, loans. We are sending requests. We are sending credit score 1 and 2. And there is a REST client exception with credit score 1, which is what is expected. But credit score 2 is working fine. So that is good. We get the loans data, we get accounts, we send to the calculation of the offer, and we get the offer as well, and we see the offer here. Okay, this works fine. Let's try one more error scenario, because that would be, I'm now quite curious what happens if the other service also fails. So this should give us an error back. Let's say this also throws an error. Restart services application. And now try this again. Now this should result in error, but let's see what happens. We go and check the logs. So we are, okay, some error. We are basically, let's go to the eBank application. We first get the customer details, then we are requesting accounts, loans, both the credit scores, and both of them are failing. So we see this REST client exception 2 times for score 1 and score 2. And then we have failed exception in credit score service. This is interesting to notice because in the previous call, we didn't see this. So basically, one of the services failed, but the join method did not fail because we set the joiner to 1 successful execution. And now both the services are failing, therefore the join fails. We go to the loan controller, which also fails, and says something is wrong, it cancels all the tasks, and therefore we get this 500 error response back. Okay, so we have seen a couple of error responses as well. I think scoped value have also been discussed, so I'm just going to move over to the last part, where basically this is the QR code to all the source code that I have shown. And if you have any questions or anything else, remarks, you can always reach out to me on my social handles here. And if you did like the talk, you can also rate it nicely in the app. Now, while you take your phones out and then start rating 5-star, I just want to quickly summarize the talk, what we discussed. So we looked at the 3 features of Project Loom: virtual thread, structured concurrency, and scoped values. And we saw how we can use these features together in a Spring Boot applications. And what we saw is that when you use these features together, we can write readable concurrent programs. And I hope that was useful. Thank you.